Okay, I've got three questions for you. The first two questions are about quadratics, and the third question is about logarithm. If you had taken a math course over Algebra 2, you should have all the tools that you need to solve these questions. So you are supposed to be able to solve them. But were you? Were you able to solve them? I guess most of you couldn't even understand what the question meant. These questions are kind of medium to hard level questions in the corresponding topics. And the reason why you couldn't solve these questions was because you are so much used to solving just one-dimensional problems, like simple basic ones that your school gave you. Let me just tell you this. You know what? My 7th grader could solve this question. He understood what the question meant, and he was able to explain how to solve this question in his own words. And for the second and third question, I went over this question with a Chilean high school student. In the beginning, he was lost. But once he figured out what the question meant and how to make connections, how to use basic characteristics of what he had learned before, he was able to solve them fairly easily. So don't you want to be able to solve these kind of questions easily, like that? Then let me just go over each question with you so I can teach you how to use the tools that you've already got at your hand. Okay, let's begin. The first question. Here, you've got two quadratic functions. The first one is y is equal to 2 times x plus 1 squared, right there. The one that opens up. And then the second equation, function, y is equal to a times x minus p squared plus q, right there. And those two functions passes through each other's vertex, right there and right there. And let's name the vertex y is equal to a x minus p squared plus q, a. So vertex of this function, a, and the intersection point between y is equal to 2 times x plus 1 squared, and the line passes through the points a and parallel to the x-axis as b. So there's this line that passes through point a, and which is parallel to the x-axis, right there, this line. The intersection between this line and the function y is equal to 2 times x plus 1 squared, let's call that point b. And we are given that the length of line segment AB is equal to 4. Then what is A times P times Q? So here, we are given two functions in their vertex form. So at least if we are going to examine the given information, we know that the vertex of this point should be minus 1, 0, and vertex of that point should be p, 0, not p, 0, p, q. And from here, if we know the characteristic of quadratic function, this question can be solved fairly easily. So we know that for any quadratic functions, there is a line of symmetry that passes through the vertex. And for this one, I'm just going to change color so we can see this better. So line of symmetry means that the left-hand side and right-hand side of this line of symmetry is exactly symmetrical, same. So if the line segment AB is equal to 4, then since these two parts are equal, each part should be 2. Do you see this? Then, once we figured out the distance between A and the line of symmetry is 2, and line of symmetry to B is 2, we know that the x-coordinate for this vertex is 2 units left of minus 1. So the x-coordinate for this vertex A should be minus 3. And the y-coordinate for A should be same as y-coordinate for point B. And we know that we know the function that passes through B, which is this function. And this happens when x is equal to, from 2 units to the right of -1 should be +1. So when you plug 1 in there, you get 1 plus 1, 2. 2 squared, 4. 4 times 2, 8. So this should be 1, 8. Which means automatically Q, the y coordinate for vertex A, should be 8. So we found what P and Q is, -3 and 8. Then the only part that we're missing is A. So let's plug P and Q in first. So y is equal to A times x plus 3 squared plus 8. As you can see, this quadratic function has been shifted to the left by 3 units, so plus 3. And then this quadratic function has been shifted up by 8, so plus 8 right there. The vertex is at -3, 8. And in order to find out what A is, we need another point, the last point. And we know that this function, this A whatever function, passes through this point -1, 0. As you can see, passes through each other's vertex. So let's plug this -1, 0 into x and y to figure out what A is. So when x is equal to -1, -1 plus 3, 2. 2 squared, 4. So 4a plus 8 is equal to 0. So if you subtract -8, or if you subtract 8 on both sides, you get 4a is equal to -8. And if you divide both sides by 4, then you get a is equal to -2. So we found everything. A is equal to -2, P is equal to -3, and Q is equal to 8. So A times P times Q is equal to -2 times -3 times 8, which is that's 6. 6 times 8, 48. This question is not as hard as it seems, isn't it? That's why a 7th grader can solve this. And of course, you can solve this now. And let's move on to the second question. Here, if the equation square root of 2x squared minus square root of 3x plus k is equal to 0, with k a constant, has two solutions sine theta and cos theta, where theta is in between 0 and pi over 2, then what is the value of k? So in this question, you need to be able to make connection between quadratic equation and trig properties. So here, before we actually get into the question, let me just prove something to you. So for some of you already know this, but for those of you who are not familiar with this concept, I'll go over. So the general form of quadratic equation should be ax squared plus bx plus c is equal to 0. And let's say the two solutions in this equation is equal to alpha and beta. Then we can rewrite this equation as x minus alpha times x minus beta is equal to 0. When you expand this, you get x minus alpha plus beta, x plus alpha times beta is equal to 0. Or actually x squared. I made a mistake. X squared minus alpha plus beta x plus alpha times beta is equal to 0. So let's go back to the left hand side and let's divide everything by a, so we can make the coefficient of x squared equal to 1. So we can directly compare this equation, this equation and that equation. So if you divide everything by a, then you get x squared plus b over a x plus c over a is equal to 0. And we know that these two equations are equivalent. So if we write x squared plus b over a x plus c over a is equal to x squared minus alpha plus beta x plus alpha times beta, then we know that the coefficient for x, which is in the left hand side, b over a, positive b over a should be exactly same as minus alpha plus beta. If you multiply minus 1 to both sides, then you get alpha plus beta is equal to minus b over a. So sum of the two solutions is equal to minus b over a. And we know that the constant part should be the same. So c over a is equal to alpha times beta. So with these two properties in mind, let's go back to the question. So we know that two solutions are sine theta and cos theta. So x is equal to sine theta and cos theta. So if you divide the first quadratic equation by the coefficient of x squared, which is square root of 2, then you get x squared minus square root of 3 over 2 x plus k over square root of 2 is equal to 0. And we know that sine theta plus cos theta, which is the sum of the two solutions, is equal to minus the coefficient of x. So that should be square root of 3 over 2 plus, since we are switching the sign. And we know that sine theta times cos theta, so product of two solutions is equal to this value, which is k over square root of 2. Then now, how can we combine the sum of two solutions and the product of two solutions? Let's square the sum. Then we get all the terms. So sine theta plus cos theta squared is equal to square root of 3 over 2 squared. Here, this is perfect square. Then you get sine squared theta plus 2 sine theta cos theta plus cos squared theta is equal to 3 over 2. Oh, here, what is sine squared theta plus cos squared theta? Which is 1. So 1 plus 2 sine theta cos theta is equal to 3 over 2. Let's subtract 1 from both sides. Then you get 2 sine theta cos theta is equal to 1/2. Let's divide both sides by 2. So we are left with sine theta and cos theta. Then you get 1/4. We know that sine theta cos theta is equal to k over square root of 2. So this is also equal to k over square root of 2. So 1/4 is equal to k over square root of 2. If you multiply square root of 2 both sides, you get k is equal to square root of 2 over 4. Right there. That's how you can that's how you can connect quadratic equation with other, like let's say here, for example, trigonometric values. That's how you can solve this kind of question. Then let's move on to number 3. What is the domain of the function f of x is equal to this weird looking log base 2 of log base 3 of log base 2 of log base 3 of log base 2 of x? Here, if you know the basic property of logarithm, this question can be torn down into really like smaller pieces that you can easily digest. So the basic property is that domain for any logarithmic function, let's say ax, this part has to be always greater than 0. So x, domain for this function is x greater than 0. So which means that this whole part has to be greater than 0. Do you see this? Okay. And if this whole part has to be greater than 0, which means that this part has to be greater than 1. Because log a1 is equal to any base of 1 is equal to 0. Anything to the 0th power is giving you 1. So with this in mind, too far. So with this in mind, we know that this part has to be 1. So if this part has to be 1, then this part has to be 2, because log base of a is equal to 1. A to the first power is 1, or log base 2 to the first power is 2. Then after that, if the whole part should be 2, then this number, the number that goes right here, has to be 9, because 3 to the second power is equal to 9. Then in order to get log base 2 of x is equal to 9, then we know that 2 to the 9th power is equal to x. What is 2 to the 9th power? That's right, which is 5/12. So in this case, for this function, x has to be it has to be greater than 5/12, because the domain for the biggest, like this outermost part, has to be greater than 0. Okay, so how are you doing? Were you able to follow my explanations? Were they easier than you expected? I'm sure they were. And if some part didn't make sense, go back and rewatch the video until it makes sense to you. The best thing is bring your pen and paper and work on your own. That's the best way to learn. And once it makes sense to you, make sure try this part. So you try to explain how to solve each question in your own words. If you can do this, then you master this concept. So for those of you who are satisfied with one-dimensional, simple, easy questions that your school offers, that's great. I mean, being satisfied, being happy is nice. But my courses are not going to be helpful for you. But for those of you who wants to learn more, who wants to be ahead of everyone else, who wants to expand your knowledge, who wants to gain really like at least 90 or average 95 or above in your math next year, and gain 7 out of 7 in IB math, I offer you Algebra 1, Algebra 2 intensive courses, in which not only giving you the big picture of what you need to learn about algebra, high school algebra, but beside that, I'm only going to get you prepared for SAT and IB tests. So if you're interested, if you want to gain competitive edge over everyone else, I'll see you in my class.